Let's determine a quadratic function from three ordered pairs. Alright, so here are our ordered pairs, -1, -2, 2, 1, and -2, +1. We're going for a function that looks something like this. F of x is equal to ax squared plus bx plus c. And again, that's a standard form for a quadratic function. And what we'll do is we'll evaluate this function in general, meaning this. We're going to evaluate f of a -1, focusing our attention on the first function. So from this, we're going to have, first ordered pair rather, so we'll have a times a -1 squared plus b times a -1 plus c, that has to equal a -2. So if we clean this information up, we have something that looks like the following. A minus b plus c is equal to a -2. We'll evaluate in a similar fashion the second ordered pair, f of 2, knowing that this is equal to 1. And that looks like the following. A times 2 squared plus b times 2 plus c, and that is equal to a +1. And from that we obtain the following equation, 4a plus 2b plus c, and that is equal to 1. And finally, we'll evaluate the third ordered pair, f of a -2 equaling 1. And we know this to be true, so I'll let you do this on your own. We obtain the following equation. We get a 4a minus 2b plus c is equal to a +1. Now that we have our three equations in terms of three variables, let's solve for a, b, and c. Alright, here are the three equations. The first thing I would do is multiply both sides of our first equation by a -1 to obtain -a plus b minus c equaling 2. Now, we're going to take this transformed equation and add it to the following two equations. And the reason we want to do this is to make our c terms disappear, and we'll have two equations in terms of a and b. So let's do that vertically here. We'll write this under each of those, kind of work in a vertical fashion. -a plus b minus c is equal to 2. Same equation right here, and we'll get back to this in one moment. So adding down the columns here, we obtain the following equation, 3a plus 3b. By design, the c's cancel. That is then equal to 3. So we now have an equation in terms of a and b only. Let's look at our third equation, 4a minus 2b plus c equals 1. Again, adding our transformed equation number 1 gets our c's to cancel out. And from this we obtain the equation 3a minus b is then equal to 3. So we now have two equations in terms of a and b. So let's take this equation, 3a minus b equals 3, and let's sneak this under our second equation here, our first one rather, 3a minus b is equal to 3. Let's multiply both sides of the equation by a -1. And watch what happens here. Rewrite the whole thing. 3a plus 3b is equal to 3 minus 3a plus b is equal to a -3. So by design, what happens? Our 3a's cancel out. Adding down the columns, we come up with 4b is equal to 0. Dividing both sides by 4, we obtain b equals 0. So our b coefficient for our function will be 0. Now our challenge is to find a, and we can take this b equals 0 and plug it back into either one of our two equations that were in terms of a and b only. And from this we have 3a plus 3 times 0, which is simply 0, is equal to 3. Solving for a completely, we're going to divide both sides by 3, so we have now the a coefficient, which is 1. Alright, one more remaining step. We got to come up with our friend c here, so we'll take a equals 1, b equals 0, plug it back into any one of our three original equations in terms of three variables, and solve for c. So I'm going to pick the first one here. It's kind of nice. We have 1 minus 0 is equal to c, plus, get that plus in there, plus c equals a -2. Subtract 1 from both sides, and we obtain c is equal to a -3. So we now have our coefficients a, b, and c respectively. Let's put that back into our standard function for a quadratic function. F of x is equal to a, which is 1, times x squared, plus b, which is 0, I'll just write 0 here, times x minus 3. And let's clean this up. I'm not real happy with that right there. So let's write this as f of x is equal to x squared minus 3. So this is the parabola, the quadratic function that goes through the points, -1, -2, 2 comma 1, and -2 comma a positive.